Is represents the equal sign. Everything to the left, or everything before is on one side of the equal sign. Everything on the other side, or to the right of is on the other side of the equal sign. And that would give us a formula like this right here, right? X equals 7 plus W. What would you do to this formula to find out what the width is? Right. And can you tell me, when you look at this formula, how is or why is it hard to intuitively figure out what W is? Why is it very hard to figure out what W is when you're looking at the sentence and much easier when you're looking at this equation? Hmm. There's a lot of layered issues here. The first really layered issue is they're telling you what X is. And because of that, they're using that 7 more language, which pushes you very hardly to say, like, oh, look, there's 7 more in C. But there's also the element that it's just really, really easy to turn yourself backwards with this language. Um, I strongly encourage students to either use one of two heuristics. One is this is heuristic, and the other heuristic is thinking which one is supposed to be larger. The which one is supposed to be larger heuristic is more flexible. There's more ways in which you can use it, but it's a little bit more demanding as well. Here, which one is supposed to be larger, X or the width? So if we're expressing the width, should we take something away from X or add something to X to end up with a result that's smaller than X? Right. And that's the sort of thought process that leads us to answer choice D being correct without setting up a formula like this. Okay, well, what should you do if you are uncertain? If you're trying giving this a shot and you're unsure of what's going on the real test? Well, we showed off an example of another framework that lets us get through this very consistently. Plugging in a real number. Yes. Plugging in a real number is really powerful for a lot of reasons, and what it boils down to is it lets you think through a situation in a less complicated fashion and then come back to it and return it to its more complicated state. Mhm. It's something that lets you think about a, a more concrete version of a problem and then return it to its more abstract form. And this is very, very widely applicable. It can't be used on every problem, but it's really, really powerful when it can be used. Speaking anecdotally, a lot of the hard math that I've been able to figure out on my own has been based off of creating an example scenario with real numbers and then reverse engineering how it works. And I'm not like someone who is an overwhelming savant at math, but I don't think that I'm just chump change at it compared to a high schooler level. I do think I am chump change compared to any real mathematician. I don't think that I'm close to being close there. Um, but compared to a high schooler level, I would say that I'm fairly strong, a little bit okay. All right, then we're on to question 10. This is a question that I'd really like you to be able to get right 10 times out of 10. And there's a lot of different ways that we could get it right. Plus b. Oh, okay. That's potentially acceptable. That is an acceptable route to do this, yes. It should be negative 5/3 times negative 6 plus b, not negative 5/3 times positive 6. Yes. When you check your work, when you check your original answer, did you make the same mistake on the test? Did, no, you can just press hide correct answer and explanation, and that'll let you see what your original answer was. Okay. Uncertain of how we got to that one then. Like, that's clearly related to the slope, but I'm not sure what led that to being the y-intercept. That one looks mostly to me like you just got confused. Mm. So there are like 3 routes through this question. You could take the route that you chose, you could take point slope form, you could draw a picture. All 3 of those would let you get to the right answer for this one. But this is a question that I would really like us to be able to get right every single time. Why am I doing this all in one window instead of creating multiple windows so that I can write my notes and look at the question like I usually do? It's a mystery. It's really unclear why I'm not doing the thing that I usually do because it makes my job feasible. All right, I've fixed my screen formatting. Question 11 is a question that might look intimidating, but it's also one that I would really like you to be able to get right every time. Mm-hmm. Are you setting them both equal to y? Is it giving you diagonal lines or vertical lines when you do this? If it's giving you diagonal, then it should be equivalent to y. Or it should be doing the same thing as equals y. Okay. I wanted to make sure because if it was giving you 2 vertical lines, that strategy wouldn't work. That strategy would be fundamentally flawed if it gave you 2 vertical lines. Mm-hmm. Now that's exciting. B is, in fact, the one answer that cannot result from this scenario. For this one, I do want to talk about other ways to get it beyond just graphing, though. Because if the answer were 0, well, it's really hard to tell if 2 lines are parallel, right? So what could we do in that sort of scenario instead? Well, first things first, do you think that you could solve the equation 12 times x minus 3 equals negative 3 times x plus 12 for me? If you just wanted to calculate what x was, what could you do? Honestly, I'd just distribute first. 12x minus 36 equals negative 3x minus 36. I'd add 36 to both sides. I'd add 3x to both sides. 15x equals 0. X equals 0. So the solution is x equals 0. There's one solution. And this is where I usually expect people to make mistakes. They see x equals 0 and then they select D. Clearly something different went wrong here. You took a viable, although odd, strategy for this one, but I would like you to take a look at this next problem as well. I'm going to be writing it out in Adobe. Can I ask you to solve this problem for me? And what does that mean? So how many solutions are there? What if I change the plus 3 over here to plus 2? Right. And once again, all of the variables cancel out, but we're left with a false statement this time. All of this works the exact same way as it does with systems of equations. So for a question like this, I would usually turn to doing it by hand. I don't think that graphing it's a bad choice. It's not a wrong choice. But I feel like that would often take a little bit more time than just calculating the answer to this one by hand would. Okay, then we're on to question 19. 19 is very silly. 19 is a question that many people get wrong exactly once, and then they're angry that they got it wrong and they don't get it wrong again. What would you multiply a number by to increase it by 400%? That is incorrect, I'm sorry to say. What would you multiply a number by to increase by 50%? What about increase by 100%? Increase by 200%? Yeah. Yes. So then, can you tell me what the right answer is? It is not 15. There we go. Percents use very precise language. 60 is 500% of 12, and it's 400% larger than 12. So if it's X% of something, then you multiply just by that percentage. But if you're talking about X% larger or smaller than a number, then we care about that percentage relative to 100%. So we multiply by 5 in this case. Excuse me. I'm just dying. I'm passing away. Then we're on to question 20. With question 20, What's something that would help you answer this problem? What is a macro strategy that we'll want to do to understand this better? Absolutely. Now I'm going to freehand this circle real fast. Here we've got the center with coordinates HK. Can you tell me approximately where on this circle point A would be? So mostly up a tiny bit right, is that what you mean? So then here is point A, which is at h plus 1, comma, k plus rad 102. Where's point B? No. Damn. Yeah, you're talking about over here. Hmm? B could also theoretically be over here, but it could only be in those two positions. Anyways, now I'm going to freehand some straight lines because I'm very good at drawing. That's not a straight line. I am very good at drawing, though. They call me Michelangelo on the streets. Mm-hmm. 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 Yo, and what type of triangle? Are you telling me that we can draw a right triangle in order to crack apart a circle-based geometry question? This is shocking to me. By Jove. Hmm. Yeah. A really good number is what it's going to be. Hmm. Hmm. Lovely. I'm sorry, what? Ah, that's unfortunate. It does look like there were a number of decisions we made on the test that were somewhat suspect. Um, it didn't feel like this question took a huge amount of prodding for you to get through it. It looks to me like, similarly to many of these other problems, it's probably within your scope, and it looks to me like, given the time pressure on the test, a lot of that didn't end up quite coming together. That's currently my best read on what went on in this test, which is like obviously something to improve on as we keep going, but also I think it's a fairly good sign that it doesn't look to me like you're outclassed by these problems. It's just a matter of like, how can you get to these conclusions in a timely and reliable fashion? Hmm. Interesting. The work of that might have been intuition then. Your brain might have seized on a connection other than the one that we drew out here, maybe. But I would like to continue to note that whenever you're in the coordinate plane and whenever you're dealing with circles, drawing triangles is really powerful. Just absurdly powerful. Do you want to see a very brief example of a situation that's like incredibly difficult if you try and solve it proactively and much easier if you just draw some right triangles? Oh, I would be surprised if you'd done this one in geometry. Here's the point 1 comma 1 and the point 2 comma 3 and the point excuse me, that can't be 2 comma 3, that's supposed to be 3 comma 2, and the point 2 comma 5. What's the area of this triangle? It's really, really bad to figure this out, right? If we wanted to figure it out, we need to like find this distance and then find where an orthogonal line intersects here. So we need to calculate a perpendicular line to this passing through this point, and then use a system of equation to figure out where it intersects, and then use that to figure out what the height is. It's a huge amount of work. Unless, unless, unless we drew some right triangles. And specifically, what if we drew some right triangles like this? It's a rectangle, but is it easy to find the area of this rectangle? Is it easy to find the area of this right triangle? Hmm? They're straight vertical and horizontal sides, so you know it's got side lengths of 1 and 4. What about this triangle? Is that one also pretty easy to find? And is this one also nice and easy to find? So if you can find the area of the rectangle on those 3 triangles, can you find the area of the central triangle? By doing the rectangle minus the 3 easy triangles. Now, I hope this doesn't show up, but it shows up in the SAT question bank. I think this question's really, really tough because it requires a huge amount of ingenuity to think of a way through it. That's not objectively miserable. Showing off another problem, this is a problem that only requires a middle school level of knowledge, but it's very challenging. Here is a hemicircle. It's half of a circle. Let me choose some good links for this at least. There is a parallel line that is parallel to the diameter. The diameter, I will say, is 20, and the parallel line has a length of 12. What is the distance between these two lines? This question is incredibly difficult and only requires a middle school level of knowledge. Both of those things are true at the same time. It needs you to know the definition of a diameter, the definition of a radius, and it needs you to know one very basic formula, and that's all that's necessary to solve it. No. We can find the area of it, but we can't find the area of that upper wedge, and if we did it wouldn't help. Well, you can draw a triangle whenever you feel like it. This question is all about, can you figure out a helpful triangle to draw? The moment you can, the question is trivial. But understanding what is a helpful triangle to draw is extremely challenging. Mm-hmm. What sort of line are you asking to draw? From just a straight line straight up from the center of the circle? Got it, got it. Something like that. That is a right triangle that includes the height. Mm-hmm. And now you're encountering an issue. We need to know two sides of a triangle to find the third. So either we need to be able to find the hypotenuse of this triangle, or it's not the right triangle. It doesn't necessarily have to be a right triangle, but if it's a triangle where you know a lot about the side lengths, then you can probably do some things with it. Do you know what those other sides are? How would you know those sides? I will tell you, you do know those other sides. And in fact, it is one of the three things that I mentioned that you need to know. However, I'm giving that teaser knowing that you've already forgotten what I brought up. Uh, we need to know what a diameter is. We need to know a very basic formula. And there's one other thing that I brought up that I'm not saying here and now because I'm very rude. It is the Pythagorean theorem. That's one of the three things we need to know. Yeah. We know what a diameter is. We know what the Pythagorean theorem is. We're just missing this one other very, very basic geometric concept that has to do with either circles or triangles. They are radii. Yeah. And it's probably useful at some point to have a vertical line for us, right? From hmm, it is 8. Yeah. It's the Pythagorean theorem. So, this is sort of a great example of how difficulty of concepts in math are not related to the difficulty of problems in math. You can be dealing with very basic concepts and have very, very, very challenging questions. Or you can be dealing with very complicated concepts and have very straightforward questions. And drawing triangles is broken. That's our other really big takeaway. Drawing triangles is a broken strategy. We need to nerf triangles. We need to get Leibniz in here with the patch notes, saying that like triangles problem solving coefficient has been nerfed by 30%. True, true, true. I think that's very easy to do. On one note, despite the fact that you had a tough time with all of these questions that I thought were in your scope, it looks to me like you got question 21 correct, which is the question I see people get wrong most frequently on this test. Phenomenal job. People get completely lost in that question. The fact that you navigated through it appropriately is very exciting. And then 22. This is causing me a little bit of harm. Mm-hmm. You cannot visually intuit that. You should do some math to calculate what the approximate slope is. I'm listening. B is the second best answer. And if you choose B, I think that's an acceptable mistake. I'd like to ask you some guiding questions. Here's the point 1, 1, and the point 2, 2. What's the slope between these points? Now I'm going to multiply all of the y coordinates by 2. Here's the point 1, 2, and the point 2, 4. What's the slope between these points? So when we multiplied all the y coordinates by 2, so the correct answer should be Well, is this question asking for you to do very precise math? Well, when we're looking at the answer choices, is the difference between calculating 6 and 5.8 meaningful? Is the difference between calculating like the y-intercept is 50 or 40, is that meaningful? Right. So this is not a question where you need to be very involved in super precise math. The most precise math you need to do here is getting a good approximation of what our initial slope is. From there, you're just asking, okay, well, I know it's 4 times larger than what I calculated. Is 4 times larger than what I calculated closer to 6, or is that closer to 1.5? Incidentally, before we move on, I want to expand your understanding on a certain front. I told you that you could not visually intuit what the slope was and that you had to calculate it. Why can we not visually intuit the slope in this graph? That's not quite it. How wide are each of these squares? Right, it's 2 wide, but it's 5 tall. We can't visually intuit the slope at all because these are depicted as squares when they're representing something that's 2.5 times as tall as it is wide. So any efforts to approximate the slope from looking at the graph are not going to give you very accurate results because the x and y axes are on very different scales. This concept is pretty important to understand when it comes to interpreting graphs. Okay, so then, this has been interesting. It felt to me like pretty much all of the problems that you got wrong were within your scope or were like 1 or 2 little tidbits of information away from being pretty easy for you. Yeah, but you also got a number of questions right that were substantially harder than the questions that you got wrong. So this is a test where I am not 100% certain what to make of the results. Like if we're looking at the more meaningfully difficult questions, I think that 13 is more difficult than most of the questions you got wrong. I think that 14 is more difficult than most of the questions you got wrong. 15 is way more difficult than most of the questions that you got wrong. I think that 16's substantially more difficult than most of the questions you got wrong. People get 19 or 17 wrong much more frequently than most of the ones you got wrong, but I think it's similarly difficult. 18 is maybe more difficult. I don't know. 20 is like the one that we got wrong that I think is really challenging. But then you got 21, which is one that students get wrong even more frequently than 20. You got that one correct. And that's one that you cannot get right via guessing. So it's very hard to figure out exactly what was going on here. We dropped the ball on a lot of questions that I'd like to be really, really accurate, but we also locked in on a bunch of really tough problems. That could mean that our test taking abilities are just somewhat inconsistent, that our peak abilities are very strong and we're not always locking in. It could be that this particular test was a little bit stilted while we were taking through the math section. It's hard for me to get a perfect read on it. Mostly my read is we're going to continue experimenting a little more as we keep going. I don't hate the results. I think the results are telling me that you have the possibility to do better. Okay. Now, what would I like to do with some of our remaining time? We've been doing a lot of work on the math side of things today, and the math side was a little bit weaker on the test. Are there any practice problems that you would like us to work on together? Excuse me. Are there any practice problem types that you would like to work on for our last few minutes in class? Um, we dealt a lot today with things going on in the coordinate plane in some capacity. Let me take a look at the question types that we actually got wrong real fast. There was one percentage. There was the circle. There was the scatter plot and the linear function. There was the one. There were the two geometry adjacent problems. I'd recommend probably either something in the coordinate plane or something geometry adjacent. Sure, let me see what I would like to toss at you from over there. Because I don't want to toss that chapter at you. That one I think would not be as useful. I could toss potentially this in your direction. Sure. This one's not horrible. Let's take a look at some myriad nonlinear functions for our last few minutes in class. And we will start around question 11. Mm. Graphing it would wind up being well, no, you could type in 7x equals the absolute value of 37 minus 5x. You could type that into Desmos. But this right here is the first step that you are missing. Which is, if we wanted to solve it algebraically, we just type this out. Or we would just write this out and solve it from here. It should. It should give you a straight vertical line. Desmos, if you type a one variable equation into it with an equal sign, gives you a vertical line where the x-intercept is the solution. That's quite important to know. It looks like I might have just genuinely not talked about that with you. However, it will usually not highlight the x-intercept. So if it's not an integer, you might need to approximate it. $3.086? Let me... They sure do be negative. There's one that isn't. This one should give you... Let's do some math to see if we can figure it out by hand, yeah? Because it's always possible that I screwed up when writing the problem. That happens from time to time. So when you're solving an absolute value equation by hand, first you isolate the absolute value, and then it splits apart into two inequalities. One is just as is, 7x equals 37 minus 5x. And for the other one, the far side becomes negative. Negative 7x equals the absolute value of 37 minus 5x. Not the absolute value anymore. We took that away, excuse me. So, what do you get if we solve this first equation? Yeah. And what about if we solve the other equation? Mm-hmm. And only one of them is an answer choice. That's a good question. I don't have a great answer for you, but I've got that's a good question. Let me double check that real fast. Maybe this one is an extraneous solution for some reason. Oh, this one is an extraneous solution. That's really unfortunate. I'm going to have to change this problem. It's an extraneous solution because it makes the far side negative. So I'm going to tweak that shit real fast. Thank you for bringing this one to my attention. And then this is chapter 1011b. Okay. Before we start to wrap class today up, I would like to double check. Have you used all of the Blue Book practice tests or not? And if you haven't used them, I'd like to know which ones you have remaining. I'd like to take note of that. That sounds like all of them to me. As well as some of the really old ones. Okay. So something that you might want to consider if you haven't done it yet is the Princeton Review book. I'd like you to have a few more practice tests before the test. And the Princeton Review book comes